So the first derivative test looks a little intimidating at first, but it's exactly what we just talked about. So let me explain what it means. Let C be a critical number. So remember, a critical number is where the derivative equals 0 or undefined. And the or undefined is a big one people forget about. It's a critical number of the function that is continuous on the open interval containing C. Now notice it says continuous, not necessarily differentiable. In other words, we would kind of throw that out. And C has to be in the interval from A to B. So C is in the interior of the interval. So you might, the parentheses are actually a little bit better for this. So C is somewhere between A and B. If F is differentiable on the interval, except possibly at C, so you shouldn't really have that many more corners except for the ones you're looking at, then F of C can be classified as follows. So what happens? If the derivative changes from positive to negative at C, then it has a relative maximum at that point. If the derivative changes from negative to positive at C, then it has a relative minimum. Now what happens if it does not change? Then you do not have a relative max or relative minimum. So what's that look like? Okay, so think about like x cubed. You have a relative maximum in there? No, and you might say, well, why are we even talking about that? Well, x cubed, the derivative of that is 3x squared. That equals 0 at 0. Oh, right there. But there's not a max or min there. Think about it. It increases and it keeps increasing. So, if it does not change, you do not have a relative max or a min. Alright, so what are the steps? First thing, take your derivative. Define critical points. Second step, plot your critical points on a number line. Doesn't matter how many there are, plot them all. And this is the first derivative sign chart. And your third step is analyze. If it goes from positive to negative, then you have a maximum. If it goes from negative to positive, then you have a minimum. If it doesn't change, you don't have anything. And you have to analyze and state in complete sentences. Okay, and those sentences are basically what you see right up above here. So let's try one out. We'll do a pretty straightforward one here. So the main thing here, first thing, find your critical points. So 4x cubed minus 4x, take out your 4x, and you end up with x squared minus 1. So you end up at x equals 0 and plus or minus 1. So we get a lot going on here. So those are our critical points. First step, find your critical points. Second step, you want to label this f prime of x. Because you can have an f of x chart, you have f of x chart, you have f prime of x chart, you can have a second derivative chart. Negative 1, 0, and 1. It's important that they're in the right order. Alright, so from here, we just have to find our signs. So plug in negative 2. Now if I plug in negative 2 here, I end up with a negative 8. So negative 2 squared is positive 4 minus 1 is positive. So we have a negative, decreasing. Most of the time they're going to switch signs, but you can't always assume that's going to happen. Alright, well, let's try out negative a half. So that makes it negative 2. Alright, negative half is a little bit trickier. So negative 2, negative positive 1/4 minus 1. And 1/4 minus 1 is negative 3/4, so we have two negatives, make it a positive. Increasing, decreasing, increasing. And then we have to try positive a half. So we end up with 2. And then 1/4 minus 1, same 1/4. We have a negative. It's 2 times negative 3/4 is negative something. So decreasing again here. And then, okay, so these little tick marks don't make that much sense unless you put them on both sides as you're looking up here. So it's decreasing, so I made it go down here. Increasing here, so it goes up. On this side, it's still increasing because it's still that half. decreasing here, and it's also decreasing here. So these little tick marks don't make sense unless you put them on both sides. And they're the same on each side. So we have positive half. Then 2, we get 8. And we get 4 minus 1, or 3, another positive. So these help a little bit, but it's really the signs you want to look at more than anything else. So if you put the little tick marks go in there, you can see the maxes and minimums kind of in here. So anything's got a plus, the tick marks are going up. Anything's got a minus, the tick marks are going down. So I mean, I can keep on putting tick marks going up, but it really is at the end points that matters. And I can see the minimum, I can see the maximum, I can see the minimum. So from here, the last step is to analyze it and to actually write your sentence, which the first couple times you write is going to be a little brutal. So what you want to say is f of x has a, it doesn't really matter which one you say. Just start with relative max first. And actually I should do this right the first time. Relative has a relative max at x equals, well, we have a max at 0. But you have to tell them why. Since f prime of x changes from positive to negative at x equals 0. And it's not much fun to write that whole sentence out, but you really want to write it out. You want to show the AP crew that you know what you're talking about. Very, very similar to the other one. F of x has a relative minimum at x equals, well, there's 2 of them. It goes from negative to positive here, it goes from negative to positive here. Plus or minus 1. Now, really, I'm being a little bit lazy on this. As a relative minimum at, with the word at, you'll probably get away with this, but try to write it all the way out. But the second part is the more important. Since f prime of x changes from negative to positive at those points. So that's very important that you write the full sentence out. You say where you have the relative maximum, minimum, and why. One of the big things people use is they start talking about increasing and decreasing. That is, it's a tricky one because you can say that the function changes from decreasing to increasing at this point. You do not want to say that the derivative changes from decreasing to increasing. That's something else entirely. So because the derivative is negative, the function is decreasing. So you could change this sentence to say, since f of x goes from decreasing to increasing at that point, but I would avoid that entirely because it really is kind of a slippery slope and it wants you to say, people get so used to saying that f prime of x. So do not go with the increasing and decreasing version, although that is still a possibility.